Thanks for being here on yet another virtual conference. But I've already attended a physical conference here in Paris, so things are happening, things are moving. So hopefully one day we will be able to catch up face to face. So I have a few slides, so let's share my screen. And let me show you my slides. So it's just a couple of slides, and then I will move on to coding. So this talk is when Quarkus meets MicroProfile. It's going to be quick set of introductions on Quarkus and MicroProfile, which last 5 minutes, and then I will do some coding, and I will give you the link about what I'm doing, so you can repeat it easily at your place, at your work. Okay. So my name is Antonio Goncalves. I'm a Java champion because basically I'm a developer, but I've worked with Java and microservices, but I've also wrote some books. I talk at conferences. I organized Devoxx France. So that was the conference, the physical conference I was talking to you about last week. And because of that, I've been awarded Java champion many years ago. So not just about my Java skills, but about all the things I've done around it. I've always been in the distributed world because coming from Java EE, I was doing remote EJBs and distributed systems, etc. SOAP, and now it's called microservices. So that's what I'll be showing you today. You can follow me on Twitter. You can check my blog where I write a few technical articles. Enough about me. So this talk, I'll quickly introduce Quarkus. I'm sure that most of you have heard about it. Maybe you're using it, but now Quarkus is nearly 3 years old, so you might have heard of it. So that's why I'll introduce it quickly. Quickly introduce MicroProfile, which is slightly older than Quarkus, maybe not as known, but very important. And then I will do coding. And then that's the end. Okay. So, by the way, if you want to interrupt me with a question, feel free to unmute and ask your question, because if you're gonna write it on the chat, I might miss it. Or you can wait until the end, but you know, it's always easier to ask questions while the problem comes. Plus, I feel less alone, because to be honest, talking in front of a webcam is a bit weird. Anyway, so what is Quarkus? The way I like to define it is actually to go back to the website. So you go to quarkus.io, and on top, you see that Quarkus is supersonic. So that gives you a sensation of speed. Subatomic, that gives you a sensation of size. And Java. I quite like this catchy phrase because sometimes we are not very good at doing advertising, but I think in 3 words they really summarize Quarkus. Supersonic, as you will see, development is really fast. I will start Quarkus and barely shut it down. So as a developer, you really go quickly, you add code and it just starts itself. Then also as a runtime, it's really fast. So if you come from Java EE or even Spring, you will see that the startup time, the response time is really fast. And I will go to the very end to GraalVM, which makes binary even smaller and faster to start. And talking about small, that's what the subatomic is. You know that executable jars are quite small, and I will explain you why. And of course, the resulted binary is also small. And Java. I think it's quite important that they put Java here, because a lot of people think that Quarkus only runs with GraalVM. That is not true at all. Quarkus runs on Java hotspot, and sometimes you can compile your code into binary thanks to GraalVM. I will not dive into the why sometimes, but GraalVM being very aggressive, sometimes you take a legacy code and it just does not compile with GraalVM. So anything you will use, all your in-house frameworks, all the jars out there will work with Quarkus on Java hotspot. And even if the Quarkus supports other languages like Kotlin and so on, it's really a Java first thing. Okay. Then there's the second catchy phrase that I also like. It's called a Kubernetes native. It is important to stress out that Quarkus does not need Kubernetes to run. I will not be using Kubernetes. But it's important that they keep it in mind. So no matter what they do, when they develop a new feature, around Quarkus, they keep the cloud and Kubernetes in mind. So Quarkus runs without it, but if you need it, Quarkus will help you. So it's a, Java stack again, tailored for hotspot, very important. Hotspot comes first, GraalVM comes second, and crafted from the best of breed Java libraries and standards. And I think that's what makes Quarkus outstanding. There's a few frameworks out there that you need to relearn. Everything is new, so you need to start from scratch. But the good thing with Quarkus is it comes from Red Hat, a company that has created, Hibernate, REST-easy, and so on. So all these libraries, if you've been using Hibernate for 20 years, because Hibernate is 20 years old, it will work on Quarkus. So you don't have to reinvent the wheel and relearn, APIs and so on. So I quite like this definition: fast, small, standard Java. Okay. Then comes the micro profile. So that might be slightly more unknown, even though it has been here for a longer period of time. So the micro profile, it's really Java for microservices. If you look at the history of microservices, for the last decade, we've heard microservices can't be developed in Java because in deployment in the cloud, they will not scale, they will be slow because of the runtime, etc., etc. Plus, there are few design patterns to implement. We don't have any standards. Java EE never standardize a few microservices design patterns. So it's important to know that what microprofile is. It's basically microservices, a set of microservices design patterns implemented in Java. Implemented and standardized. That's also the beauty. It's standardized at the Eclipse Foundation. It's open source. Anybody can contribute to it. And of course, there's several big players. Red Hat, of course, IBM, Microsoft, and so on. You can contribute. The mailing list is open. Everything is in the open. The code is in GitHub. You can create issues. You can participate. So the microprofile specification, there are only a few. Open tracing is a specification that allows you to chain all the logs, all the distributed logs, among microservices. Open API, if your microservice exposes a REST contract, then we have a specification to expose and customize this REST contract. REST client, so, you know, if you have a one microservice is not a microservice architecture, you need several ones. If they expose a REST contract, there's the specification called REST client that allows you to easily invoke a remote microservice. Configuration, you often need to configure either one microservice or a bunch of microservice using different sources. It can be a property file, it can be a variable environment, and so on. So the config specification is here for that. Fault tolerance, when you invoke a remote microservice, it usually goes wrong once in a while. What do you do? Metrics, you want to know how the system is performing. JWT propagation, once you're logged on, you need to propagate tokens. So there's another specification to help you. Health, so that allows you to know if your system is healthy or not, which are the nodes that are down. So these are the only specification that are published now in the MicroProfile specification. There are others, they are still being worked on. They might integrate the MicroProfile, but basically that's the 8 final specification that we have at the moment. That being said, there's other specifications that come from Java EE that have been introduced into this MicroProfile. So CDI, very important, context and dependency injection, JSON processing, JAX RS for REST endpoints, and JSON-B. So we have the JSON binding and processing that work hand in hand with JAX RS. So in the code that I will be doing, I'll use not all the specification, but most of it. I will develop HTTP microservices using JAX RS, but I will also use a reactive client listening to a Kafka, and that uses the reactive messaging specification that is being worked on and hopefully will integrate the MicroProfile in the next release. Okay, so I'll be using that plus reactive messaging. Okay. Yeah, it's here, sorry. So what will I build? I want you to give you the diagram, the architectural diagram of what I will build, so it's easier to represent. I'm going to create one microservice that creates books. So that's a REST endpoint. It exposes a contract. I can invoke it with a curl, with a browser. I pass it the title of the book, and basically it will create a book in JSON. Very, very simple. I might not have time to persist it in a database. So I have a REST endpoint that creates book. So I do HTTP post with a book title, and it returns a few extra information. One of these information is an ISBN number. When you create a book, you need an ISBN number. For that, I have another microservice listening on a different port. So I'll be using port 8701, 8702, and I will do an HTTP call. So when I want to create a book, I do a post on the book microservice, and this one invokes an external microservice to get an ISBN number. I'll make sure all the tests pass, so you know how easy it is to test with Quarkus. But what happens when the network breaks down? Well, I'll have another microservice, but this time it will listen to a Kafka stream, a Kafka channel, sorry. So when everything is okay, the book is created using an ISBN number. And if I can't get this ISBN number, then I'll push a message to a channel saying, sorry, one of those days when you have time, please create a book. And at the very end, I will package that with executable jars, but also binaries with GraalVM. So I will turn all that into binary, a Linux binary, and package it within Docker images. I might not have time to build and package all the 3 microservices because, as you will see, GraalVM takes a bit of time, but I will do it at least in one. Okay. And remember, all the code I will be coding is there on my GitHub repo. There's also the README. So now I'll be following the README. You can follow it yourself. So really, it's a README, do this and do that and type this and type that. So I'll be doing it for half an hour. And please feel free to go to this URL and check the code and do it yourself. Okay. So let's code 3 microservices with Quarkus, with Hotspot and GraalVM, create Docker image and all that in 30 minutes, fingers crossed. And remember to get the code. So that's the end of slides. Now a bit of code. I have here a totally empty structure. The only thing that I have is a few shell scripts. So again, these shell scripts are in the GitHub repo, and there's the README that you can follow. So the one I'm following right now. So really, I'm developing everything from scratch here. How do I create a microservice with Quarkus? How do I create a project with Quarkus? I can go online to code.quarkus.io and I can answer a few questions, click, and I will download a zip. Or I can use a Maven plugin. So that's exactly what I've been doing here. So this is a Maven command with the Quarkus Maven plugin, and I'm going to create a project. I give it a group ID and an artifact ID. So here I'm creating the microservice book. So it's called book. The class name. So this way it will create a book resource, a bit empty, but with a LOL happening there. It's a REST endpoint. So I have a path. It's /API/books. And I'm going to need what Quarkus calls extension, REST-EZ and REST-EZ JSON-B, because I'm doing JSON. Okay, so I have nothing here. I'm going to my terminal and I execute this shell script. So I execute bootstrapped book. So that's exactly the same shell script. And what it does is it creates a Maven project. That's all. So here, let me do that. It's clearer. So what happened behind the scenes is it has created a book structure, a Quarkus. So, as you can see, there's a POM XML with everything in it, with the right group ID and artifact ID, all the needed information for Quarkus. Then you have SRC. Under main, we have Docker files that we will be using, and a book resource. Remember, that's the book resource. That's the name that I've passed to the Maven plugin. It's a book endpoint listening on /API/books, and it returns REST-EZ on an HTTP GET. And because I've told you that I'll be using several microservices listening in different ports, I can go to resource application properties, and by default, Quarkus listens on port 8080. And I can say, no, please, Quarkus, listen on port 8702. That's it. So now, how do I start Quarkus? I need to start the Maven plugin. So Maven Quarkus dev, and it starts Quarkus. That's it. And I can even curl. So here on the window, I do a curl localhost 8702. So that's the listening port /API/books. So that's the one here. And it returns hello rest easy. That's the text. Well, fantastic. But really what we want is to create a book. So this method, hello returning a string, we're going to call it create a Quarkus book passing a title. I will consume text. So the title is just text. But what I will do is I will return JSON. So it returns a book. Very important, sorry. It's not an HTTP GET, it's a post. I want to create a book. So that returns a book. So let's create a class book, public class book. Okay. And a book has a title. So that's the attribute I'm passing. It has a topic. It's mostly Quarkus stuff. What's very interesting here is the ISBN number. Remember, that's the number I'm going to invoke a different microservice. And so we have a bit, we see what's happening. Let's put a timestamp created at, and that's instant now. This way in the logs, I'll have something moving, and let's generate a toString method. Okay. So now in this method, well, what do I need to do? I need to create a book. So that's new book. And in book, I have the title. So the title is the attributes title that I pass to the resource. Then comes the topic. Let's say the topic is always Quarkus. Then, well, it comes the ISBN. So that's really where we need to invoke the microservice. And let's put some logs. So the good thing with Quarkus is we can inject a logger, the org JBoss logging. There's several loggers it supports, but we have the logger here. And let's do book created, and let's pass the book and return the book. Okay, so now I have a curl. I have a curl command that does an HTTP post in text plain, passing the title. So here the -d is the data that I'm passing. Remember that I need the title here on /API/books. So yeah, here I can create as many books as I want, and you can see the logs with the timestamp. I haven't started, stopped and restarted Quarkus. Now there's something nice with Quarkus in the last versions is there's a dev UI. So, oh, sorry. So here I go to 8702/Q /dev. So under /q, you have several endpoints. And here it shows me the configuration of my microservice, listens on port 8702. And as you can see, there's some documentation, some information on the beans. But because it's a REST endpoint, I would love to have an open API contract. Guess what? Really easy. I go back to my IDE and I'm going to add an extension. So here I'm using, again, the Quarkus Maven plugin. I'm adding an extension OpenAPI, which basically doesn't do any kind of magic. It's, oh, sorry, I had to do that under book. What it does really is it creates OpenAPI. Yeah, it just adds a new dependency on the POM XML. I could have typed it, but I like to use the terminal. So now I haven't stopped, done anything to Quarkus. Adding an extension, it hot reloaded itself. Therefore, if I refresh my dev UI, I have the Open API. So I can click on Swagger UI, and here it is. I can create a book. I can try it out. Book, new book. I do an HTTP post, and here it is, a new book. Okay, let me just do a git commit, so book, so it's easier to follow. I told you that testing is really easy with Quarkus. So let me go to my tests. When we generated the project, it has generated a test, with rest assured. When I do an HTTP GET on API/books, yes, it returns hello rest easy. Well, I've changed the code, so this test doesn't run anymore. And look at here. In fact, Quarkus has hot reloading and hot testing. So what I can do now is, so this method is called should create a Quarkus book. So that's a test. And remember that I need to pass a title. So given a body, I'm giving the body title of the book. I could have done whatever I want. It's not an HTTP GET anymore. It's an HTTP post. And then when I do that, let me copy paste quickly because I can see that I'm going to be running out of time. What I'm doing here is I'm matching the JSON title as the value title of the book. Indeed, it's here. The topic is Quarkus. Remember, all the topics are Quarkus. And in the JSON, there is a key called ISBN, and there is a key called created at. So as soon as I save this file, the tests are automatically executed, and look, tests pass, fantastic. I could also do, I've done a Maven test, just a normal Maven test. That works while Quarkus is up and running. Why? Because when I do a Maven test, Quarkus starts a new Quarkus on a different port. So here I have two Quarkus listening on different ports. And when the test finish, the second Quarkus disappears. So far, so good. So let's commit that. So I git add, git commit test. Okay, now let's create the second microservice called number. You remember, I have a shell script, more or less the same one with a different artifact ID, but so when I execute this shell script, what happens? Well, I have another Maven project called number, and as you can imagine, same thing, number resource. it is a REST endpoint listening on /API numbers, and it returns hello REST easy. So let's rename this method hello to generate an ISBN number. I'm going to do the same thing. Let's copy paste. I'm going to inject a logger. Here it is. And I'm going to generate a random ISBN number. So here I'm really cheating. I'm generating a string that starts with 13. It's a random number from 0 to 100 millions, and I log it ISBN number. Okay, so now same thing will happen if I go to number and do Maven Quarkus dev. So I'm starting, oops, sorry, I forgot about changing the port number. I need to listen to port 8701. So let's do that. 8701. So now when I do Maven Quarkus dev, it starts on 701. I can curl it. So you will see that it works. So it generates a number. The only thing is if I press R, like to resume testing, the test will not work. Why? Well, you might have guessed. The generated test looks for a body that is hello REST easy. And what I'll do is, well, the body in fact starts with 13 dash. So, any number that starts with 13 dash. Fantastic. You've seen how easy it is to test, hot reloaded, hot testing. I haven't done, anything with stopping and starting. Let's commit that number. Well, I have two microservices running, testing. One creates books, the other one generates ISBN numbers. Let's make them talk to each other. So when I do a curl, okay, what I would like now is to have a real ISBN number instead of we need to invoke the microservice. For that, I need this specification REST client that I've mentioned before. That's another extension. So I'm using the Maven plugin, again, to add an extension called REST client. What does it do? Just a dependency on the POM XML. Okay, nothing too fancy. Look at what I'm doing now. I'm on the number microservice, and I'm doing a copy paste of the number resource and pasting it on the book microservice. And I'm calling it number proxy. So the number proxy is not a class, it's an interface, meaning that I get rid of all the code, but I keep the annotations. So that's very important. It's just a proxy to an external microservice. So it needs the path of this microservice. It needs to know that the method does an HTTP GET and returns plain. The only thing that is missing here is an annotation coming from the REST client specification called, please register this interface as a REST client. Basically, the magic happens here. Now, what I need to do is I need to inject this proxy. So number proxy, and instead of doing an inject, I'm doing an inject with this qualifier called REST client, also coming from the REST client specification. And now, well, instead of a string here, I will go proxy generate ISBN number. And now I can do an curl. Oh, it's failing. Why? Well, because it doesn't know where the microservice is. So here, the stack trace tells me, please set the property where is the microservice. So here I'm setting the property, the microservice is, so where is the URI of the microservice? Well, it's localhost 8701. Remember, 8702 is book, 8701 is a number. So now, if I do a curl, everything works. Fantastic. So you see that I can create a book with a generated ISBN number. So that is cool. I just introduced a relationship between book and number. So that means my test, the book test pass, great. But because they are linked together, if I kill number, unfortunately, my test will fail. What do I need to do? Well, mock the invocation. Really easy to do. I go on the book tests and I create a class called mock number proxy. This mock number proxy implements number proxy. Therefore, it implements the method ISBN number, and I return mock ISBN. The only thing for this to work is I need to annotate the class with mock, that is a Quarkus annotation, and REST client, you know, it's the same qualifier. So now if I resume my test, yes, it's working. So really now I have these two microservices talking to each other and can be tested in isolation. Let's commit. So REST. Good. Okay, but kind of good, because what happens if I do a curl and the number microservice is down for any reason? Maybe the network is down. Well, that's when we need to do something when there is a failure. So that's when we introduce the fault tolerance specification. What do? We introduce another extension, small-ri fault tolerance. So that's another dependency on the POM XML. Oh, there is a problem. Don't know why. I'm restarting Quarkus. Sorry, there was something weird. I'm using the latest 2.3 version that was released a few weeks ago. So yeah, so what I would like to do is, here I have a problem with the proxy. If this method does not work, I would like to do something else. So this specification tells you, well, create another method with the same signature. So let's call it fallback on create a Quarkus book. So here it returns a book and it gets a title string. I keep the same signature, and here instead of that, I will go, I don't know, I can set a string, and it needs to be set later as the number of microservice is down. Okay, so this is not an info, is a warning. Here I can go up, sorry, warning, and book not created. And the only thing I need to do for this to switch is add the fallback annotation. So here I'm going, please, if there is a problem, fall back on this method, fall back on create a Quarkus book, which is here. And that's it. So now, if I do the curl, I'll have the warning. So it doesn't fail miserably, you know, again, I have a warning. So that is nice. So this is how easy to add a fallback. Let's commit. Okay, but I'm not doing anything. It falls back, but I'm not doing anything. So now what I'm going to do is, when it falls back, I want to send a message to a Kafka channel. For that, what do? I need a new extension, the messaging Kafka extension. As I told you, it might be a specification that will get into the microprofile reactive messaging. So I'm adding this yet another extension, and then I have new APIs. So here I'm injecting a channel. A channel as a name. So here the channel is called failed books. I failed in creating a book. And as you can see, I have an emitter of type string called failed book. So what I do is, when I fail in creating this book, I'm sending to this Kafka channel the book to string. Remember that I have a string representation of the book. Now, the only thing I need to do on the producer part is to say, look, I have an outgoing channel called failbooks. Remember, that's the name of the channel we inject. The connector is a Kafka connector because I could connect to different things. And what's inside is a string. So please serialize the message as a string and send it. Good. So now I need the subscriber. Well, guess what? I have another shell script. I'm not going to show you because it's exactly the same thing. So I'm going to create a third project called book fallback. And so it's here, book fallback. And it's not, it has generated some code, but I'm going to get rid of all of it because it's not a REST endpoint. So here I'm copy pasting all the code, sorry, because I'm running out of time. What's important here is the incoming annotation. So you see here I'm emitting on a Kafka channel called failbooks, and here I'm receiving the message in failbooks. And I'm going to need the same configuration, but this way I'm saying failbooks is a receiver and there's a string. The message is a string. So let's start Maven Quarkus Maven Quarkus dev. And here there is something amazing happening behind our backs. Now, Quarkus is saying, by the way, you need Kafka. I don't see any Kafka up and running in your development machine. Let me start one for you. So it uses test container and Docker to pull a Kafka image. If I need a database, it will do the same. So I do not have a Kafka up and running. So that's Quarkus starting a Kafka runtime. So that's very useful. And now, as you can see, each time I create a book, it fails. Therefore, it sends a message to the Kafka stream. I even have a script here that loops and creates books. So now when I start the number microservice, you will see that in a while, well, the book microservice can get ISBN numbers, therefore it doesn't send a message in the channel. And if I kill the number, then it sends messages to the Kafka channel. And now I'm totally running out of time, totally. Is there any question while I'm doing something that's going to take a bit of time? I'm going to actually take the number microservice and compile it with GraalVM with just one command. So sorry if it was a bit quick. While the compilation is happening, we have 3 minutes for a question. So let me know if you have a question while GraalVM is compiling. So there is no question, and GraalVM is compiling slightly faster than I thought. But I'm on an iMac Pro, a big machine, and it's taking a lot of CPU. What I wanted to show you is I've been starting Quarkus in development mode. So when I start Quarkus, it takes a bit of time. I can do an executable out of it, an executable jar, but I can also make a binary. So now under target, you can see this binary. It's 39 megabytes long, and I just executed, and it has started in 0.2 seconds. And so if I curl, if I curl the number, it is it is the ISBN number. It has started in 0.2 seconds. So, that's the supersonic bit. And if I do Maven Quarkus Dev, it is much slower to start because, as you've seen, it is always in watch mode. It compiles things behind our back. It detects that a test class has changed and so on. So that's why it starts in 1.2 seconds and the binary in 0.02. So thanks to GraalVM, we can produce very small binaries that do not need a JVM to start. That's why Java is slow in the cloud, because the JVM needs to start, the runtime needs to start, and so on. With that, we have short binaries that start very, very quickly. That's it. I also wanted to show you how to Dockerize that very easily in one command, but I do not have time. So please, if you want to check the code, all the code is under this URL. And I also have the README with all the things I've typed, so you can easily follow it. I think that's it. So thanks for attending the talk. Sorry for being slightly fast at the end. And do not hesitate to go to the URL and follow the exercise on your own. Well, bye-bye. I leave you with the end of the conference. Bye.